This is going to be a fun, exciting session. It's going to be about the demonstration of the OntoTrans system, and I'd like to invite Natalia. Yeah, here she is. Natalia is on the stage, and she's going to be the moderator and lead us through this session today.
Good afternoon, everybody. Welcome for our demonstration section of OntoTrans workshop. And I'm very happy to say now that we will present 3 parts of OntoTrans implemented now, and we can demonstrate how it works together, namely triple store, exploratory search system, and API. This work has been done by the colleagues from 3 institutes from University of Bologna, the team from Alessio Morra, Alessandro Calvio, and Luca Foscini provide this work with triple store and triple store, and the next team from Faja, Ekaputra, and Florina Piroi from Technical University Wien worked on the exploratory search systems. The team from SINTEF, namely Kasper Andersen, Thomas Hagelin, and Jasper Fries, worked on the on the knowledge and data interconnection technology. And we would like demonstrate all this technology for OntoTrans based on one translation case, which Mikhail Nosky will explain us. It is the collaborative work, of course, from the whole consortium. And yesterday you heard a lot of theoretical basis of these technologies. And today we would like to show your praxis, how it works and how you can use it in the future. I will give you the navigation of the section today, starting from OntoTrans training framework and how we provide this education training and some kind of glue of the consortia based of key development steps of the project and deliverables to involve the consortium in the continual professional development. And the colleagues from 3 institutes will show you this exploratory search systems, triple store, and knowledge and data interconnection technology. On the end, we will have the time for discussion and some maybe remarks, and your feedback from this technology will be very, very nice. Welcome from a whole team. For OntoTrans, this exploratory search systems, ESS, provides a graphical intuitive access to existing relevant information stored in the knowledge base. In our case, is OntoKB, and facilitate the process of translation by providing immediate representation of connection between ontologous entities. The OntoKB, or triple story, is the knowledge base of the OntoTrans system, and it manages semantic knowledge necessary for open translation environment system. In fact, it is not only storage ontologies and individuals, but also enable the reasonable capability of semantic data. And the technology which bring all together will be shown today by SINTEF team, and it will show how mappings can be used to achieve full semantic interoperability by linking properties in data and data models ontological concepts. This thing will be demonstrated by used OTE lib and OTE APIs. From my side, I would like to start to speak some word about the OntoTrans training frameworks, which is really unique in the frame of EU projects. I would thank Alexandra Simpler from Goldberg Consulting for her enthusiasm and very, very high professional levels as trainer. And we as training team created the special concept to bring this multidisciplinary consortium to continual professional development. It is the focus was to find the common language for all of us in this very huge, really huge multidisciplinary consortia to bring the understanding of technical basis of the development and needs for the successful of this very ambitious project. We looked at the knowledge which could be provided from this consortia, which collected of people which are in the consortia and objectives of the projects. And we provide the fine line how we can develop these points to bring these deliverables from the consortium and to bring people to work each other. The education of the consortium member on the level of PhD professors and very, very high educated persons is a very important aspect, and it is needed for the internal cooperation and for co-creation of OntoTrans platform. And I'm happy that Alex is with us and we are working together, very, very efficient in this direction. We are now in the middle of the project. We worked 2 years and we created 19 internal events. It is trainings, interactive workshops, webinars, tech cafe. And you can see people who are members of the consortium, and I would like to thank all our trainers who bring their professional level, their time and their knowledge for the whole consortium, and who educate all our members and bring this continual professional developments for consortium member. In the other case, this OntoTrans training framework has very strong social aspect. It is the glue of the consortium, and especially for this special time of pandemic time, this online activity time, it was very, very nice approach to bring us together, to give us possibility to cooperate and to co-create. In other case, we are very, very happy to see that this approach is integrated for other projects and other consortia use it, and we're happy to see it. It is our achievement as well. We created our training framework and our materials in this sense that we can reuse these materials, and we organize free external events. It is first of all EMMC webinar in December last year, one co-creation with a section in ECOMAS in 2020, and now this demo session as reuse of the materials, internal events with some kind of adaptation. So what we can demonstrate today. All of you saw this picture sometimes yesterday. It is the basic high-level logic architecture of our OntoTrans platform. And today we will show you this part, exploratory search system, which will be presented by a team of TU Wien by Vaja, and the theoretical part was presented yesterday by Florina. Second part from the team developed from the team of University of Bologna, Luca presented yesterday all content of Triple Store and OntoKB, and today Alessio will show you the practical examples which was developed by him and Alessandro. And the connection part part of APIs and how you can bring together all knowledge and data developed by Sintef will be presented today by Jasper and Caspar, and Thomas is the co-developer of this technology. He's, I think, in the workshop as well. All this technology we will demonstrate on one exemplar use case, composite purpose use case, which will be explained by Mikhail Noske. And I would like to invite Mikhail now to present here. Only some words about Mikhail and why he will present this case. Mikhail is a researcher at the Department of Adhesion and Interface Research at the Fraunhofer Institute of Manufacturing Technology and Advanced Materials, IFAM in Bremen. His very high professional level as researcher and as applied researcher give him the possibility to work as translator on the interface between industry and academia, and these translation skills Mikhail demonstrated yesterday, and I think that now he can bring us more understandable view on the case which we will present here for OntoTrans.
Thanks a lot for the introductory words, Natalia, and also Gerhard. Good afternoon, ladies and gentlemen. You will see I have got an easy part today. I'm basically mimicking an end user who would then contact OntoTrans with an industrial need. So we now have to think how translation works until the exemplary use case finally is defined. And yesterday we heard that this is quite a process and that human beings have to interact in order to define the innovation challenge, to frame the innovation case, and then to identify a use case. We would like now to jump a little bit into the topic that we have shortly also introduced yesterday with respect to composite pre-breaks. As you see in the image on the right-hand side, from this material which is transported and delivered on a roll, we now would like to make a product, and I would like to give the story behind, a short exemplary story. So next slide, please, Natalia. In the end, what has already happened when we are at the use case level is the first steps of the 6 steps following these translation step processes. And we have then a good understanding of the business process and a good understanding of the industrial case already. And finally, then the translator goes a little bit into the data, into a workflow, and he may be supported by the translation environment, the open translation environment that is set by OntoTrans. So next slide, please. Thanks. So let's suppose the following scenario a little bit. An organization on the enterprise level has identified an industrial need and internally made up an assessment of a business case. That means we are already on the level 1 in the frame of a macro process within the enterprise. So we do not need to consider the user that has already been considered by the top management. As a consequence, then the business case is the frame of our innovation case, and in more detail may make up a use case or user case. The business case is the frame. That's basically the boundaries then for the innovation case. So what then might now have happened after a long enterprise internal meeting? Finally, the unit manager would summarize the internal needs, telling to his team or her team of R&D engineers, find some sustainable pre-break that is suitable for us, designing the reusable handbar of our eye-catching new shopping carts. Very precise. So the R&D engineers hopefully have understood the business case around a shopping cart. The R&D engineers face the industrial, the use case challenge, find a pre-break material and a pre-breaking process, which are suitable for the manufacturing of a handbar with a perfect surface finish in the enterprise's existing setup of devices and tools, because that is most suitable, fastest, cheapest, and that is basically then the way how the enterprise may make money. And that is how often in practice, somehow internally, communication is very much to the point. So the innovation challenge is then communicated in one sentence only. Now we will follow the progress achieved by a team of research and development engineers when contacting the OntoTrans team and going into a little bit more details of the translation and translators work. So enjoy the subsequent demonstration steps.
Thanks a lot, yeah, Michael. So now we will go to demonstration case. And first demonstration case is exploratory search system, which will be presented by Faja. Faja Kaputa, researcher at TU Wien, focused of semantic web technologies for data integration and advanced application in various domains, including physical systems, person data management, and smart city. And now Faja will present his or that work of TU Wien on the exploratory system, search system of OntoTrans. Faja, please, floor is yours.
Hi, hello everyone. I am Fajar Kaputra, and thanks Natalia for the kind introduction. Today, I will provide a demo on the exploratory search system in the OntoTrans environment. Just before I start, I would like to acknowledge the work of my colleagues that makes this presentation possible. Firstly, for Kevin Haller, which provide the solid foundation of the ESS system, as well as Rafael Feudel, which together with me has been tirelessly working to make this demo possible. Okay, so to continue on the story of Michael before, when the R&D engineer contacted the OntoTrans team to find sustainable pre-preg for this reusable handbar for this new eye-catching shopping cart, this translator then contacted the OntoTrans team, and they will be provided with an interface, the one that you see right now, and check there that the use case that this translator wanted to do is actually supported, this first one here. And note that this wizard is currently under active development. So this is more like the clickable demo, but not yet finalized. And you will have a chance actually to provide feedback as well, and where the link to this place to provide the feedback will be provided later at the end of the demo. Okay, so let's assume that I am the R&D engineer that's being tasked to do this translation that and Michael is my boss that's ask me to do that. In here, when I see this, I can click on the use case that I want to do, or the innovation case that I need to do. And I say that I would like to focus on the process optimization. And then in here, we are reusing existing model to represent the pre-pregging process. So this is, we are using the model deployment, not training. And in this part, we need to provide some configuration, like what type of resin should be used in this model, type of fiber, and so on and so forth. Of course, as an engineer, I would like to see something as a starting point. Is there any historical data, something that has been done before? So then I can have more or less estimation on what kind of information that I should put inside of here. And here, this is where the exploratory search system, or for short, we call it ESS, is coming in. You see that there is this button on the left side here. When I click on it, I will go to the ESS, the exploratory search system, where I can being supported to look into the information that I need. The ESS, just to remind you once more, is that a system providing graphical interface to allow for exploration of information stored in the knowledge base. And currently, just for context, we are hosting a small amount of, like a tiny part of the whole MO ontology. This is even not all of them, concept that is inside of the MO ontology. But just for today demo, we are focusing on small part of it. You see, there is this like red circle, and we are focusing on that, where we have this pre-pregging process that has two inputs, resin and input fabric, has a number of steps that needs to be done, has a certain manufacturing methods which produce in the end a pre-preg roll as an output. Okay, so with that background, let's go here. And now I want to be supported to do this pre-pregging, right? So I search for pre-pregging. This is online, by the way, so you can also take a look on that. And in here, you will see that it contains some information that is related to the pre-pregging. Another note, this data that is shown in here, all of them are generated from openly available data. So no proprietary data is used for this demo. Get back to the example. So this, we have several instances of the pre-pregging. Let's take one. And in here, you can see that this is an information of the previous like pre-pregging that has been done. So it has certain input, like which resin, which textile fabric, which method is being used, information about the geometry of the lamination, the steps that's being done, as well as the output. Let's take a look one by one. So in here, for example, you have the example resin that's being used. It has some properties of it. If the number doesn't really make sense, I apologize in advance. So this is being generated, so might not be representing the real value. But here you can see that from certain resin, you can know that, oh, okay, for this pre-pregging, they are using this type of resin. This is for the fabric. So you have information about which fabric is being used and what is the characteristic of it. The techniques that are being used, like which manufacturing method that's being used to do this pre-pregging, for example, is compression molding. And one thing that probably you realize that in the bottom of the information, you have these related manufacturing methods. In here, the ESS will has this capability to integrate a customized algorithm to compute what kind of information is the most similar to the one that's being shown. For example, in here, where somebody is looking for compression molding, the system will try to propose other object that could be relevant for the user that's searching for this object. Think about an e-commerce system where you're actually looking for something and then they will propose to you what would be the related items to that. This is kind of similar to that. The same also for the fabric, resins, as well as the pre-pregging. That's more on the input side. And then how about the process? Here for this pre-pregging 10, it has 5 steps inside, where the first step would be the heating, and then you do there is a dwelling step, another heating, curing, and the last one is the cooling part. This is the step that's being done in this prepregging 10. As a result, you get this prepreg role with 0.03% porosity. That would be an example of information that you can search across this ESS, where you can use that the data that's provided here, this historical data as inspiration to then fill in the information for the model execution in this part, in the user interface, in the wizard. That's more or less the information about the prepregging. The data that we have is currently limited to those tiny example that we have here. But later on, when we have more data, then we can explore additional information, additional data sets that can be linked to this one. Okay, that's about the prepregging. Another thing that I want to show you is that the number of different ESS feature in here. You can see that it provides in the top right different roles for different interface for different roles. For example, now we are in the translator roles, which provide 5 tabs for the result. It can also be customized that, for example, for gas, since it's not very important for them to see the other tabs, we can remove or add parts to be shown to the user. The same also with the box on the right. This can be customized. The other thing is the language tags. Here, you can switch the language. And you can see that in the data, only for those properties that has like different language tags, like this one is automatically translated to German because there is information about that. And this can be customized for different languages as needed. The next one is the search history. So because the nature of like searching around, it's also possible that you might forget like what you searched before. And here you can see like a different parts that you explore in the same tab. So then if you forgot what you searched before, you can go back and go to the same page. The two more advanced feature is that the hierarchy, where you can see like a different type of classes or concept that is available in the data. For example, in here, you will see that this emo class, this is related to this prepreg and textile fabric, which is being used in this demo. And the last one, for those that have like sparkle ability, you can also try to do that here. For example, if you want to search for type and density of resins in prepregging that is using certain methods, like vacuum bag molding, you can ask this and get the result of this query as well. Before we move back to the user interface, one thing that I would like to say is that the data that is provided in the ESS, this doesn't have to be open always. So you can always provide proprietary data as part of ESS and then make the mechanism to ensure that the data is only accessible from those that are supposed to have access to it via login mechanism or even different instances of DSS. This is possible. Okay, assuming that we have all the data that we need from here, like for example, from this prepregging, and we want to like adapt this number and bring it to this page here, there is still like a 2 question remains. The first one, how to populate the data into the ESS system before. This is magically appear there. How does it work? And the second one is how, if I already have it here, then I submit, I run this model. How to run the model and get the result. This can be done in 2 ways, like using standalone application or API-based model as transformation. But to have more insight to this, then I will hand this back to my colleagues and Natalia, please. So that's all from my side. Thank you.
Thank you very much, Faisal. Thanks a lot. Now we will invite the group of experts from SINTEF to discuss the part of the interfaces and connection of OntoTrans environment. And From consortium, 3 persons will present this work. Jasper Fries, Thomas Hagelin, and Kasper Andersen. Jasper Fries is a senior scientist at SINTEF, at the Group of Material Physics, with an associate position at Norwegian University of Science and Technology. He has a background in mechanical engineering, and for OntoTrans project, it is very important that Jasper is the one of co-authors of the AMMC and the co-developer of AMMO. Thomas Hagelin is a software engineer who is architect and leader for the development of soft and DLI, and Thomas is expert with the interoperability platforms, scientific software design and development. And Kasper Andersen is a research scientist at SINTEF. Educated in experimental crystallography, he has moved to the team of interoperability scientific software design and development, and now he is a part of the SINTEF group who is working in many AMMC related projects and develop some domain specific ontologies. Kasper and Jasper, please take the over for the presentation and speak about the interfaces in OntoTrans.
Thank you for your kind introduction. We will start with some slides, and then Kasper will take over and show a live demo.
Yeah, we should mention that Thomas is unfortunately ill and could not join. So we've tried to establish a quick on-the-fly presentation for you.
What we're going to do is we have Fadia needs data to populate the exploratory search system. And he needs it in a special format, serialized in RDF. This data is available in another format, serialized in JSON. Now we can use these interfaces. So this is a very technical part. We are far away now from the customers. So the purpose here is to take this data source and use the interfaces that we were presenting yesterday to provide the data in the form that Fadia needs. Going through several steps. So maybe we can take a quick round here. So we have the data source that connects to it here. We passes the data source into an internal format that we map to ontologies. We get fully semantic. We can then, it's still a semantic representation now of we have a data model. We create data models for the source. So the data is a semantic representation of what we have in the data source. But that is not what Fadia needs. So we need a conversion here. So this function converts from the data model of the source to the data model that Fadia needs. And then we provide it. So and the last function here simply serialize it. Okay. In order to set it up for the data source, we have created data models for the data Fadia needs. I guess you recognize pre-breaking and so on. So these are data models, and they, of course, are instantiated, and so instances of these data models exist here in the source. In addition, there exist some relations between the source. I just took an example here. So this is at the data level. We know that a pre-breaking, the first pre-breaking instance has occurring step 1. It has even more occurring steps that are related to it, but this is one of the relations that exist in the source. All these data models here are, at least not currently, but when the system is up running, we will query the OntoKB and get them. So that is part of the configuration when we are configuring our data source and before we run the pipeline. So that is essentially the two first steps. Source here that access, downloads the instances, and a parser that parse this JSON file here and creates instances of our data models. We then want to make it semantic. So we take this data model, map them into ontologies. And again, these mappings that we need, they are all stored in the OntoKB. I will come back to this step here afterwards. But the main point is that we take example of one of these data models that are needed, the querying step. But what we actually have in the source is another data model that is very similar for case of simplicity. But you can see most things can be mapped directly, label to label, description to description, type to querying step type. But here we get the querying. And it should not be initial. Sorry. It's a querying temperature ramp. That is we don't find that in our source, so we need to calculate that. But the querying duration can be mapped to duration and pressure to pressure. So there's this interesting step I will spend some time on in the end. Okay, the serialization is also quite straightforward. There is a function here, and Casper will show how it runs, and it simply just produces what is needed for the exploratory search system. So let's go back. So we have our init input and our output data models. If we now, these we need to map them. I want to show this first. So we have a simple mapping here that maps the pressure to the ontological concept pressure that is in this mapping here. At the same time, we map the output to the same ontological concept. And this way, it makes it possible for this function here now to instantiate querying. So given an instance of the querying data, we can now instantiate an instance of querying step and fill in the value querying pressure. And if we look at this here, this is actually how the mappings are formulated in OntoKB. So it's, as you can see, it's a set of RDF triples. And the one I was showing you is this one here. So here we have the querying step. The querying pressure here is mapped to the ontological concept querying pressure, actually, which is a sub. It's actually not. It's but it should. What I showed you on the previous was actually that it was a subclass of EMMO pressure, which which would be the right way to do it. In this case, it's a data class actually. And if we go back to, sorry, I was to this next step here is the interesting part where we have we can calculate the ramp temperature from the initial from an initial temperature, the final temperature and duration. We are so lucky that all this information exists in our querying data in data model. So then we actually employ a mathematical formula that can be formulated ontologically. For this, to do this, we can use the function ontology that Fadia many times has pointed out. It becomes quite messy and technical, so sorry for that. But let's try now to go through a little. It's not that difficult in the end. We have the input data model with 3 properties. is the initial temperature, the final temperature, and the duration. And we can see we can map them to ontological concepts. The duration, which is a subclass of time. The initial temperature is mapped to a concept we introduced called initial temperature, which is a subclass of the Celsius temperature. And we have the final temperature that we also can map to a class in the ontology that is Celsius. So you can see these classes here, they are more specific than the general EMU classes. So that's something we have to add to our ontologies in order to make these mappings to work. So that means that mappings are not only to write these very simple triples, but sometimes you actually have to further develop the ontologies to make things working. And that's why the mapping step is not, we want to make this onboarding of new data models simple. But so there is one step where you create a data model, and that is a step for a data engineer. It's quite straightforward. And then we have the mappings, which sometimes require actually also additional ontological skills. You have to add classes to the ontology that are precisely describe what you have as your input and output in your data models. Okay, that was it. Then we have on the output, we have the duration and the accruing temperature ramp. And again, these are properties and they can be mapped to a temperature ramp and to a duration. And we can see here, we have again a trivial mapping to the duration, so that can be completed, but the accruing temperature is more difficult. This one here, however, there is a formula expressed with this function ontology, the function that has a return value, an output producing this ramp. So we can, by going into ontology, see that there is actually something that returns a temperature ramp, and that is connected to a function. This function here expects 3 inputs: time, duration, and initial and final temperature. And all these 3, we can see, we can populate, given these here, we see they are actually instances of the classes that we have mapped to. So we can simply from our instance, our input data model, we can populate these 3. We can then evaluate this formula. In this ontology, we do it very simple. We add to the ontology simply a Python expression that shows how this should be evaluated. And then we run this expression here in a secure manner. So it's only limited what you can do in this, but it's actually evaluated here in Python, and the result here is then used to populate the accruing temperature. So that was a more technical part, but it really shows that we can do very advanced modeling mappings here.
Yeah, so we've implemented this in a Jupyter notebook. Here I'm using it through VS Code, but it's the same thing. So if you've ever seen a Jupyter notebook, this is a single cell, and then you can write in Python code or Markdown code or whatever in these, and then essentially run it. So what I've done is I've started a server using this Docker Compose file that's available, which will install a plugin for OT API that supports Delight, and it will install this specific use case and the strategies that are available in it. The first one here is just to check that we have indeed the proper packages in the environment. So we need OTlib, for example, to actually set up a client to this server. So here we have the configuration. So the server is currently running locally on port 8080 with some prefix that we then set. So normally, or rather in production, you would actually have a proper URL to some external open translation environment service that runs somewhere. with its own set of specific plugins that are available and strategies there. This is just to check that we can actually access this server and it's running. That's good. So the first thing we do is we use this OT-lib to import a client. And this client we instantiate with our URL that we defined up here. Now we run that, and now we can utilize this client to create different strategies. The available strategies are data resource, a filter, a function, a mapping, and transformation. Transformation and function are, for all intents and purposes, the same thing. Function being serial, so it's running. It's basically stopping everything and it's giving you the answer straight away, whereas transformation is running in the background. So it's synchronous and asynchronous. Yeah, the data resource is to retrieve data sources, so downloads or contact REST APIs and other services. Filter is to handle that incoming data, and mapping is for semantic mapping mainly. We have the workflow again here, or the pipeline rather. And what we can see is we need a data resource, a mapping, and function strategies. So in OT-lib, both the source and parse comprises into one the data resource strategy. So we just need one for that. Then we need separate mapping strategies for each of these as they map different things. And then 2 different function strategies as well as they do different things. Right. Yes. So we have a data resource strategy to retrieve and parse the JSON file. And because we're taking a local file, then the path will be a bit obscure and opaque to you. Normally, you would probably point this at a file online, because what you need here is really a URL. But because we are using a local file with a JSON and stuff in it, we put in a local path here, local to the server, pass it in as a URI, and then we use a media type that will invoke the correct parse strategy. This is a parse strategy that we have implemented in this as part of this use case in this plugin repository and Python package. So it's literally this one doing this stuff. Anyway, back to this one. So we create that strategy. Then we need some semantic mapping and conversion strategies. Here we have some functions to retrieve these prefixes and the triples for the ontologies, and to also create this function strategy that converts between these models, as Jesper was just discussing. Again, we're referencing here a strategy that have been implemented here, but it can be also a general one, of course.
So these 3 functions here, get prefixes and get input triples and output triples, they would in the next step actually speak directly to OntoKB. Right now they are just looking up internal database.
Yeah, this is a demo for mocking, but yes, very good. Very good. Finally,
what you see Kasper is doing, you are so fast when you're actually evaluating each step, and you see this green light when it actually evaluates.
Yeah, it's running. Yeah,
it's running.
Exactly. Yeah, and finally, we need to create the final function strategy. So notice I'm always using the client to do this OT-lib to create the different strategies. And here we put in a bit more configuration stuff. So we specify a path to where we want the output file, this turtle file, to ontology file essentially, to exist and end up being written to, and then the format is this triple format. So then we set that up as well. Finally comes the glue parts. So here we want to actually set up the pipeline. So if I go back just for 2 seconds to look at the picture again, we start out by with a data resource, then we have the semantic mapping steps with the different mappings and functions in between, and finally the serialization, i.e. writing to a file on disk. This is captured in this pipeline where we start with the source. So here I'm referencing, it's a lot of up and down, I'm very sorry. The data resource that we created, stored in this variable. And we have these other variables for the other strategies. And then we're basically referencing them here using these double carrés in between to say that we want to go this way, starting this pipeline. And then we call the get on the pipeline. And when we do that, what will happen is that it'll go to the last one and initialize that. Then it'll go to the previous one, initialize it, initialize this, and initialize that one. When we've done that, we will have a little cache that is stored with all the mapping information. And then it'll start running it forwards again. And this is the way it's built. This is the whole design. And this is I think this was discussed and presented yesterday by Jesper, this pipe filter design. So then it'll actually fetch the file and it'll parse it. And this will do nothing at this point in time. Then we will convert between the models with the mapping that we've already initialized. And again, this will then do nothing at that final point. And eventually the result will be serialized into a file. So let's see how fast that is. Oh, it's slow. So it works. It did work. All right. So what it returned is the collection ID. So it's just a little dictionary that references a UID. This is some internal knowledge that it's been using throughout to reference a delight collection. Right. And if you run this locally, we will probably at some point make this available so you can run it yourself as well. Then the file it creates, because it's created from within the Docker, has some has a bad user. Essentially, it has root user, so you need to change the owner of the file before you can access it. But if we look into the folder, what it has created, it's created this instances, and that's what you would upload then here to OntoTrans.
Yes, so that is exactly, so that is what the exploratory search system, this is just a screenshot I got from Fadia, what is needed.
Yeah.
What's interesting, and we can even take a little quick look at
take a little look at it. Yeah, this is what it looks like. So these are the prefixes that we listed in the mapping and retrieved from the mapping strategies, and then these are all the triples represented and mapped to each other, and so on and so on.
And here we actually see the actual data that was instantiated and provided. So the short story is that the OT-lib provides a very friendly way. You have to create these different strategies, but when you have done that, you have this, if you scroll up, you have very simple syntax for actually composing them into a pipeline and run it. So I think that part here is the most interesting, this
Indeed.
part that shows the how simple it actually is. You create a pipeline and execute it.
Indeed. And you can combine pipelines as well. So if you make another pipeline that utilizes the outcome of this, you could say this is the first one, and then you could make a new pipeline that goes into whatever happens next. So
is it?
New pipeline would be pipeline into something more, for example. And then you'd need to define either a strategy here, or you already have another pipeline, and so on and so on. And you can exchange parts. So you could make part of this up from different pipelines and combine them as you want. Yeah. It's very, very flexible. All right, let me see if I
Thank
can
you.
stop sharing.
Thank you very much, Jasper and Kasper. Very nice talk, and yeah, demonstration of what we can see inside of OntoTrans and how it will deliver the results. And now I would like to invite to the stage Alessio Mora from the University of Bologna to present the work of the group of Uni Bologna and to demonstrate this work regarding OntoKB, which is a knowledge base of OntoTrans system, and it managed the semantic knowledge necessary for open translation environment system. The group is Alessio Mora, Alexandro Calvio, and Luca Forcini. Some words about the colleagues. Alessio Calvio is the researcher of University of Bologna. He's working on the computer engineering, and currently he is on the study of ETSIMAC standard and the exploitation of simulation tools for performance testing. Alessio Mora is a PhD student of the Department of Computation Science and Engineering of University of Bologna, and he concentrated of his work on the different EU projects on the semantic web and ontologies. And Luca Forcini, he presented yesterday his talk about Triple Store and OntoKB. He is the associate professor of distributed and mobile system at the computer science and engineering department of University of Bologna. Luca has been habilitated as a full professor in 2020, and he is the author of more as 170 publications in journals. He is the co-author of 5 issues in international journals and 5 chapters in international books, and more as 150 additional work published with his work as well. He is concentrated in OntoTrans on the development of OntoKB and semantic web and ontologies. Alessio, please continue with this demonstration and the application of triple story for OntoTrans.
Firstly, thank you, Natalia, for the kind introduction, and also thanks to Fajar and for the nice presentation, and also thanks to Kasper and Jasper for their presentation and demo. So first of all, here I have also prepared some slides just to have a reference besides the practical parts of my demo. So today I will give you a practical overview of OntoKB, that is the knowledge base for the OT system. So just a brief reminding for everyone that OntoKB contains the ontological data needed for the OT system, and in particular for the sake of this demo, for the exploratory search system and the part that Fajar showed us before. Here, as we can see from this slide, OntoKB, that basically is an instance of triple store, and in this case of Stardog, will contain Hemmo as the base ontology, and also an application, or one or more application ontologies. In this case, for example, what we called A3 ontology, that is containing the concepts that the exploratory search system was using before. And also in OntoKB, we have we have mappings and data model stored, because as told before, as Jasper and Caspar told us before, we should have reference for the raw data. We should have in OntoKB the data model for raw data, and also the mappings to those raw data to the actual concept in ontology. I remind you that OntoKB will not store the actual raw data, so we will have those data model, reference, and mappings to then retrieve raw data and build the tagged with semantic information data that the ESS, the exploratory search system, will take in input. The demo, my demo today will include three steps. Okay, the first one, the steps are in yellow in the slide. In the first step, we will have a look of Stardog, our triple store, and we will look inside it using Stardog Studio. That is an administration panel, so we can have a real feeling of what is Stardog, our triple store. Then we will switch to trying to use OntoRec, that is a component that we built to have to facilitate the interaction with OntoKB. And then finally, step 3, I will show you a simple pipeline for OT-lib that uses OT API in a similar way to what has been shown by Jasper and Caspar. So we will use some strategies in OT API that we built in particular for OntoKB, and so to access OntoKB, to query it, and to retrieve semantic information such as mappings. So step 1, inside OntoKB, as I said, now I will show you Stardog and Stardog Studio, and we will see what is inside. So I just switch view. So here I have in the upper side of this Docker app, I have Stardog service running, that is my OntoKB. Okay, so I have a containerized Stardog that is running. Obviously, it is licensed because Stardog is a commercial product. And now I can access it by using this administration panel that is basically you can use it using your browser. So I here connect with my OntoKB, and here I can see that I already have here two knowledge bases. One that is AMO with the entire AMO, and one only with the application ontology we are using for the demo. An interesting view could be to use the graph view of Stardog, that here is quite stunning for, this is AMO, okay? The one that Fajar was showing before. It is not so easy to navigate here, but it is quite stunning, okay? At least for me. And then we can look at the application ontology we have here, that is, a reduced part. And if I zoom here, for example, we can look that here we can recognize some component that we may have seen before in the Fajar demo. For example, here we have additive and catalyst that are subclass of resin gradient. Also here I can show you the classes, and also here we can, this is the same ontology that Fajar was referring to with the ESS, so we can see here that we have a concept that we have already seen in his demo: prepreg, prepregging, prepreg role, and others. And also here you can navigate relationship, attributes, constraints, and also there is a text editor if you want to see the source code you have in your knowledge base. You can also query your knowledge base, in this case, the part that I would like to show you is about mappings, because as I said, in OntoKB, besides AMO and the application ontology, we have mappings that connects data model for the raw data, so the structure of the raw data, to the actual concepts in the ontology. So here I just brought a very simple query that will returns us all the mappings I have in my triple store. So I run it, and as you can see here, we have a number of results that are all the mappings I have in my triple store. On the left side, first of all, I'm searching for all the triples that have as predicate maps to, that is defined in AMO domain mappings, and it tells us what on the left in the results, so the subject or the triple is the basically is referring to data model, and the object on the right side is referring to the concept in the specific application ontology. So I can show you another little more articulated query, always on mappings, that this time will to retrieve all the mappings for a specific, in this case, racing data model. So I run it. I've already run it before, but on the left, we have a racing data model, and on the right, we have the related mapping in the application ontology. So it is mapping concept. And the last one, maybe a little more complicated again, but here I would like to extract all the references in different data models, because we could have more than one data models that are referring to the same concept in our application ontology. And in this specific query, I'm searching for all the references in different data models that map to a specific concept in the application ontology. And in this case, I'm searching for Turing step type in my application ontology. And let's see, we have two results, as you see on the object. So on the right, we have the same entry, Turing step type, that is referenced by two different data models, as similar as Jasper was talking us before to the usefulness of having the transformation and mappings and data model. Okay, so this was step one, and was about OntoKB and what is inside OntoKB. And then now I will show you how we can interact with OntoKB in a more controlled and simple way using OntoRec, because Stardust Studio, what we are seeing before, it is an administration panel. So we usually will access to OntoKB through OntoRec. OntoRec is a component we built for the scope. It uses fast API, so it exposes some APIs to in turn query or ask OntoKB to do something for us. I will use to the scope Postman that just permit me to simulate HTTP requests for OntoRec that in turn send them to OntoKB. So here I have back to Docker apps. I have OntoRec service running that is waiting for requests. I have here Postman, a tool that I will use to simulate requests for OntoRec and OntoKB. So the first one, very simple. I just ask here to retrieve all the triples in the triple store app3 database. That is the one we were looking to before. So if I send this query, I have here all the raw data, all the triple in raw strings. So not so readable, but they are here. And then I can send by OntoRec a query to OntoKB. In this case, I'm asking for resin data model, the same query as before, and here we are, we get back the results. Also, I can ask to OntoRec to create a new database for me, in this case called tentative ammo. So I ask OntoRec to create it and create it. We can check it by going here. As you see, I have tentative ammo, a new knowledge base here, but it is empty, triple count 0. And then I can also ask OntoRec to put something inside this new knowledge base, and I pass it here as a value. I choose M ontology that I have locally in my computer, so I can ask to OntoRec to put this file, this ontology, inside the new database. It should have been done it. Just refresh the view, and here we have tentative ammo that is not anymore empty, but that's the same number of triples as my old ammo. They are the same basically. So after this overview of OntoRec, that was our step 2 in this demonstration, we can go to the last part of the demonstration that includes something more related to what Casper and Jasper shown us. I'm going to basically use OTAPI and OTLib to use OntoRec and OntoKB. Basically, I will use custom strategy that Alessandro and I have developed to interact with the knowledge base. As we can see here, we have a data resource OntoKB, a Sparkle query strategy, and also an OntoKB upload strategy. That is the last one is for when you would like to insert new knowledge in OntoKB that can happen, for example, when you have results for a simulation you have maybe run through after the ESS step. So now we will have then a look to the code in my Python environment. This is similar to what Casper shown us before, but it is customized for our OntoKB and OntoRec. I also have here the OTAPI service running as Casper told us before. Okay, and also in my Python environment, obviously I have Python installed, and also I have here OTAPI installed somewhere, OTAPI core and OTLib, so that I can use them. And the scope of this Python script is to build a pipeline that basically create a query, a Sparkle query, that we will see then what I defined in the Sparkle query. Anyway, we will have a Sparkle query that it is passed to an OntoKB resource, and it will be run, and we will receive back the results of the Sparkle query. So I can run it. I can show you. Okay, it works. We have some results. They are JSON, and these are true results. The query that they asked is the same query about mappings. The same query we were looking before here, where I was searching for all the data model that are referring to Turing step in the application ontology. So here we also have two results as we have seen in Starbucks Studio. The first one that is to here, and the second one that starts here. again, these are JSON format. How I built this pipeline? Very simply, as Casper and Jasper told us, I firstly instantiated an OT client with the OT API endpoint, because this is, I know the address, it is running locally to this port. And then I instantiated an OntoKB resource using my plugin, my custom plugin for OntoKB. And this custom plugin is referenced by this name, data source OntoKB. I know the access URL that is basically referring to OntoRec, that, as we have seen before, in turn sends request to OntoKB. And then here in configuration, I just tell to the OntoKB resource that the database I am interested in is the one called triple store app3. And then here, again, the Sparkle query, I build the pipeline, I run the pipeline with total pipeline get, and I receive the result. Here, to connect this part with the ESS part, the Exploratory Search System part, we should add here in this pipeline some other filter and steps, maybe as the one I sketched here in the commented line. We could have, as Jasper and Casper told us, then we could have a raw data resource, because we don't have raw data in OntoKB. So we will have a reference to raw data. We can load, fetch raw data, and then have a mapping filter that actually take the semantic information from OntoKB and take the data model and adds semantic tags to raw data and give back, for example, to the exploratory search system the final objects that it needs in a format like, for example, RDF. This is the last part I wanted to show you today. The OntoKB upload will be developed in the near future. We are working to it to be able, in a similar way to what we shown with a simple pipeline as before, to upload back new knowledge to our OntoKB. So I will come back to you, and please, Natalia, I will leave the stage to Fajar again, and he will conclude the demonstration with the results. And
thank you very much, Alessio. Thanks.
Thank you too.
After all these technical details, I would like to invite to this part of the section Fajar, Florina, and Mikhail to speak more about the results to the translator for the considered use case. But before we will start, I would like to say some words about Florina Pirhoi, who is the lead of this research team of TU Wien, and who bring a lot of efforts for OntoTrans development. Florina is involved in interdisciplinary and industrial related projects in data science, focusing especially of data analysis, machine learning, and methods for their evaluation. Florina has received her PhD degree in 2004 from the Johannes Kepler University Linz in Austria, where her work concentrated of management and retrieval of mathematical knowledge and automatic theorem process. Florina has a strong interest and broad knowledge for the data science and machine learning research areas, and she contributes very, very much for OntoTrans platform development. Good. Yeah. Now we would like to discuss this very important step for translation back to end user. How end user can receive all recommendation and all decision of the system. How translator can have the support from the system. And Florina, Fajar, and Mikhail, please explain for us how it works now and which steps for development you have for the future development, please.
Okay, thanks. Can you hear me now? Yeah.
Yes, we can hear you.
Okay, so after we know a bit more about what is the process behind the OntoTrans environment, now we can go back to our model. So now, after seeing what we have in the ESS and we filled in some of the configuration, now we can start to run this the process of the model execution. It will do some checking with the OntoKB, accessing the OntoKB module, getting some data from there, and getting the result from it. So using this result, then me as a translator then can use this. I can do repeatedly, like the next execution of the model with different configuration, until at some point I can use this tool to finish my job. For example, to answer my supervisor, in this case Michael, which actually asked me to find the sustainable prepreg for usable handbar for this shopping carts. And after doing this for some time, and then getting the result that I need, for example, so before I report to Michael, I can also doing some kind of data analysis on this data, which is also part of our work in the work package 5. I mean, Florina, would you like to say something about that?
So what we didn't show in this demo until now, and is the set of tools for data analytics. So but also because for this particular application case, it is not that relevant to have that kind of analytic tools we have in mind. But as soon as you have larger quantities of data and maybe low variations, you would be able to detect outliers much quicker with some tools that you would call for the output you get from this simulation or workflow running. You could do also previously what Fajar showed is data validation that can also include some access to external data analytic tools, where you not only check that the data you input is correct, but is in terms of content correct, like there are no strings where you should have maybe numbers, there are no zeros where you should have maybe actual values or something like that. But you could do also some other types of analysis before you start your processing, so that you make sure that the conditions for your model running are fulfilled semantically, and not only in terms of code checking and error-free running. So we are definitely working a lot on this, and basically the most challenging part is to understand the needs of the industry partners. Because we do communicate in sometimes different scientific languages, let's call it like that, and often what is possible for us to do is maybe not accepted by the industrial partner to do because of proprietary issues or legal issues, and then we would have to think of not really workarounds, but solutions to still provide and abstract out from those problems and solutions, to abstract out and apply those solutions also to other cases. Yeah.
Yeah. And yeah, I mean, with that, then after we can do some data analysis on this, as Florina already said, then I can really now report back to my supervisor, Michael. So I did my job. I give the report back to you, and as an end user, then yeah, you might want to say something about that.
Thanks, Fajar. So in real life,
we didn't hear you, Michael. Probably the.
No.
Yeah, I'm sorry. So you see, in real life, I'm not a supervisor. So then you would always hear me, and you would need to hear me. I'm definitely rather a committee man. So at the other side, at your side. But now I can feel like your supervisor, and somehow then I might think, what would be the ears of the supervisor? The information that is obtained after the sixth step was translated to you in a way that you obtained somehow an idea with a material that you can work, and the pre-pregging process parameters. Now you say, I found them. That means what I hear is there's somebody who suggests do it. It works. So understandable for me, it works. It is reliable. I hope so. And usable means then let's buy the pre-preg and let's use our setup that we have in the enterprise and produce for the first use case. That's supermarket XY, was the handbar for the shopping cart. And the advantage that I would have is, in case that also a second supermarket comes in, YZ for instance, and wants to have a bar, then we could think about just changing a little bit up the design. That would not really change a lot the pre-preg material or the pre-pregging process. And in some 20 years, when the shopping cart itself might need some replacement, the reusable bar would still be there, and we could really reduce it. So I would then check, oh, what were our data 20 years ago? They are all stored in this OntoKB. Possibly the data are not in there, but all the knowledge behind is stored there. That means I would then really be able to check, is this bar still following the regulation that we have in the year 2042? And then I would say, okay, it is reusable. It was designed to be so 20 years ago, and the regulation has not changed, so let's reduce it. So I will be happy now and in 20 years, and obviously I would promote you, Fajar.
Thanks, boss. Okay. So yeah, I mean, with that, this concludes actually like the end-to-end demo on our side, starting from the beginning when Michael explained the processes, and we show how this can be look like in the GUI, how the inside of these things, those that's explained by Jesper, Casper, and Alessio, and to round it up with the data analytic part from Florina, and goes back to my supervisor, Michael. So I'll give this back to Natalia. Thank you.
Thanks a lot. Thanks a lot, yeah, Fajar, Michael, Florina, and demo team. who contribute a lot for this event.
Thank you so much, Natalia, and really all the speakers and demonstrators. You know, it was very, very nice to see everything starting to work together. And this is really, we're still in you know the first part of the project, so this is exciting to see, and hope you enjoyed that. And I would like to thank everyone again for participating, and please also keep you know with the interactions and ask questions. And as Florina also pointed out, please provide us feedback. The links are provided. Nadia, would you like to say a few words as well from your side?
Yes, I would like to thank to you also for nice moderation yesterday and today, Gerhard, and of course to thank to all speakers coming from OntoTrans project, but from other European projects, and thanks for a nice presentation on your approaches for related topics to OntoTrans. And I think Gerhard also mentioned a couple of times we will have opportunity to continue collaboration within different task groups in EMMC. So we hope that after this workshop, we immediately continue to work together. And also I would like to mention that the next OntoTrans workshop is going to be in month 40, meaning that it's already in 16 months. It's not, it's not so long, but I'm absolutely sure that in particular on this demonstration part, we will be able to present much more close to the end of the project than what we have already now. Also, I would like to remind you that these talks will be published. I think already beginning of the next week, it will be online on the project website, on EMMC website. So it will be possible maybe to hear some talks later on in the case that you missed something from yesterday and today. I would also like to thank to EMMC for using this platform, ERMeet. So it was really good opportunity to organize through ERMeet, and also for the support in the preparation of this workshop to Trust IT company, and also to Ernst and Laura, who did quite a lot of work in organization of the workshop. So that was all from my side. Thanks a lot and see you soon.